Hello students, how are you? So in the previous class, we discussed about the mole concept, various aspects of the mole, various relations of the mole, and the questions regarding mole. Now in this class, we will discuss about the concentration terms. Concentration terms are used to define the amount of substance which is present in solution. Or you can say in simpler words, that amount of solute which is present in solution is called as concentration terms. We have lot of variety of concentration terms. Then now we shall discuss all of them one after one. So now we shall continue concentration terms. In the previous class, we studied about the mole concept. What is the relation between mole and number of particles? What is the relation between mole and the volume of given substance if it is gas at STP? And what is the relation between mole and mass? Do you know, guys, what is solution? Solution is what? Solution is a homogeneous mixture of solute and solvent. So basically it is homogeneous mixture of solute and solvent. Now, if you if you prepared a solution and scientifically you want to define a solution, that what exactly is the solution you have prepared. In order to define your solution, you need to define what amount of solute is present in the given amount of solvent. In other words, that is concentration term. So concentration term is used. What is the use of concentration term? Concentration terms are used to define the amount of solute in solution. To define the amount of solute in solution. So what amount of solute is present in solution is defined with the help of concentration terms. So what concepts we shall discuss in this class, students? First, I shall tell you something about the solution. Then concentration by percentage. Then we will discuss molarity, molality, normality, mole fraction, and ppm, parts per million. Alright, so let's proceed. As I told you, what is solution, students? Solution is a homogeneous mixture of two or more chemically non-reacting species, which simply means chemically they should not react with each other. Alright, if they will react with each other, they will form the another third substance. But in this solution, it is a mixture of two or more components, but they should be chemically non-reacting with each other. And concentration of solution, that is composition, it is varied within a certain limit. The component of the mixture are not visible with the naked eyes. What does it mean? Suppose you have prepared a solution of salt and water. You have mixed salt along with the water. Once you mix the salt with the water, you would not be able to identify both of them separately. They will mix with each other in such a way, my dear students, that you would not be able to identify any one component separately, not with the naked eyes. Alright. So solution is made up of two components, that is solute and solvent. Solvent is usually of larger amount and solute is usually in smaller amount. Solvent may be water. If you prepared a solution in which solvent is water, it is called as aqueous solution, where solvent is water. And sometimes you don't pick water as a solvent. You can choose ether, benzene, CCl4 or any other solvent. So that is non-aqueous solvent. Non-aqueous solution and aqueous solution. So on the basis of solvent, there are two kinds of solutions. Now what is concentration? Today's topic. So the amount of solute which is dissolved in a particular amount of solvent is known as the composition or strength or concentration of solution. In the simpler words, you can call it as a composition, or you can call it as a strength of solution, or you can also call it as a concentration of solution. Now concentration can be described, number one, in the qualitative manner, and number two, in the quantitative manner. In the qualitative manner, as far as the quality is concerned, solution can be of two types. One is the dilute solution, in which concentration is poor, low, diluted. And the another one is concentrated solution, in which concentration is high. So if the concentration is high, it is concentrated. If it is low, it is diluted. And this is the qualitative aspect. You can bifurcate the solution in two parts on the basis of this concentration, amount of concentration, that is qualitative aspect, right? Now we shall see the quantitative aspect. Now the solution concentration, it can be expressed in much better way quantitatively, where we define the quantity, in which we define the quantity of solute which is present in the solution in the given solvent. So these are some common ways of expressing the concentration of solution quantitatively. Remember guys, here we are defining the concentration quantitatively. If you want to define the concentration qualitatively, you can define it, as I told you, two ways: diluted and concentrated. So quantitatively you can define it by percentage, very common concentration term, molarity, molality, normality, mole fraction, and parts per million, ppm, parts per million, right? So now we shall discuss all of them one by one. All right, let's proceed. So first is the percentage. What is the percentage? Percent, cent means 100, means it is defined over 100. So concentration in percentage can be expressed in three ways. Guys, it is very simple and very easy. It is mass percentage, percentage W by W. The volume percentage, V by V, and the mass by volume percentage, W by V. It is also called as percentage strength. It is also called as percentage strength. First is mass percentage. What is mass percentage? It is the mass of solute in grams dissolved in per 100 gram of solution. In the per 100 gram of solution, what is the mass percentage? Is called as percentage W by W. Now suppose someday you enter in the laboratory and you see a bottle over there. Suppose it is a bottle of HCl and it is written 5% W by W HCl. What is written over there? What is written over there, students? It is written 5% W by W HCl. Now my question is, what does it mean? It simply means 5 gram HCl is present in 100 gram solution. Important. I am not saying 100 gram solvent. Overall, 100 gram solution contains 5 gram of HCl. So in total, 5 gram HCl is present in the 100 gram solution. So in this solution, you can define out of the 100 gram, out of this 100 gram, 5 gram is HCl and remaining 95 gram is water, if solvent is water, which is most of the time water. So if it is a, I should write it over here, it is aqueous solution. Now it is perfect. And it is also referred as weight percentage or percentage by mass. Sometimes you will see the concentration written in the percentage W by W in the daily life objects, like when you buy a sauce or a pickle or any other food article, food substance. Sometimes you will see the concentration of the component in the percentage W by W. The next one is molarity. What is molarity? Molarity is the number of moles of solute present in 1 liter of solution. So suppose I have a solution which says 2 mHCl. Its symbol is capital M. 2 capital mHCl. What does it mean? It means 2 mole of HCl are present in 1 liter of this solution. 2 mole of HCl are present in 1 liter of this solution. This is called as molarity. This is the molarity, right? Now, do you know what is molarity? How to define the molarity? What is the formula of molarity? So, formula of molarity is the number of mole of solute N divided by the volume of solution in liter. Now, suppose someday in case you take the volume in milliliter rather than volume in liter. If sometimes solution is given in milliliter rather than liter, then you have to multiply it by 1000. So, if you take the volume in milliliter rather than liter, then you will multiply it by 1000. So, now you can see in this formula of molarity, there is a role of volume. So, formula of molarity involves volume, and volume depends upon temperature. It depends upon temperature. So, whenever you changes temperature of any solution, there is a change in molarity. Whenever you change the temperature, there is a change in molarity. And it is very important, guys. Molarity of solution changes with the temperature. It changes with the temperature. It has a specific value. Yes, it does. But at a particular temperature. If you change the temperature, it will change the specific value. Right. The next one is molality. Small m. There is a very small difference between the name. You see, that was the molarity and it is molality. What is molality? There are two changes. Prima facie, if you see, there are two changes, major changes. What was the capital M? What was the molarity? Previous one. Number of mole of solute present in 1 liter of solution. Now in this, rather than 1 liter, we say 1 kg. And rather than solution, we say the solvent. For the sake of your memory and for the sake of your convenience, let me tell you students, this is the only concentration term you will see in your entire life in which we will use the term solvent. Otherwise, we will never use the term solvent. We always use the term solute, solution, solute, solution, solute, solution. But specifically, molality is the only concentration term in the entire syllabus, entire chemistry. Here we use the term solvent. So what is molarity? How to define the molarity? What is the formula of molarity? It is number of mole of solute divided by the mass of solvent in kilogram. Here also, if you take this mass in grams rather than kilogram, you have to multiply it by 1000. And the unit of molarity is mole per kg. And you can see, here is the mole and here is the mass. And mass never changes with the temperature. 50 gram will remain 50 gram. No matter how high the temperature is or how low the temperature is. 50 gram will remain 50 gram only. So, molality is independent of temperature. It does not depend upon temperature. A solution contains 1 mole of solute per 1000 gram of solvent. Remember guys, solvent is called as a molal solution. If I say suppose 1 small mHCl, what does it mean? It means 1 mole HCl is dissolved in 1000 gram of solvent. If your solvent is water, you can say water. So this is molality, small m. Mass of solvent is independent of temperature. Whatever the mass of solvent is independent of temperature. Hence the molality of solution does not changes with the temperature, as I told you. So with the temperature, mass remain constant, and so as the molality. The third concentration term, another concentration term which we are going to study now, is normality. What is the normality? It is very similar to the molarity. What was the molarity? Capital M. Number of mole of solute present in 1 liter of solution. Of course, at a given temperature. Here what it is? It is number of gram equivalent. The term mole is replaced by the term gram equivalent. The number of gram equivalent of a solute dissolved in per liter of solution. Rest is same. Number of gram equivalent of solute present in 1 liter of solution is called as normality. So what is normality? Normality is number of gram equivalent rather than mole. Now we will say gram equivalent. Number of gram equivalent of solute divided by the volume of solution in liters. If you use the volume in milliliter, then you have to multiply it by 1000. And the unit is gram equivalent per liter. A question must be arising in your mind that, sir, what is the gram equivalent? We know the mole, sir. Sir, we know the mole. We studied the mole in the last lecture. Mole is given mass upon molar mass. Mole is given molecule upon Na. Mole is given volume upon 22.4. Yes, sir, we know what mole is. But sir, what is the gram equivalent? So let me tell you what is gram equivalent. Gram equivalent is the equivalent mass of solute expressed in gram. That is called as gram equivalent. So how to calculate the gram equivalent? How to calculate the gram equivalent of any solute you have? Gram equivalent of solute is equals to mass of the solute is equals to the mass of solute divided by the equivalent mass of the solute. How you define the mole? How you define the mole, guys? You define the mole by mass upon molar mass. Here in this, rather than saying mass upon molar mass, now we will say mass upon equivalent mass. So formula of normality will come as like molarity. Here we will say mass of solute in gram upon equivalent mass into volume of solution. V, but it should be in liters. It is not in liter, it is in milliliter. Then what you will do? You will multiply it by 1000. Right? So what is equivalent mass? We know the molar mass, but what is equivalent mass? So as per the definition, it is the mass of substance that combines with the 1.008 gram of hydrogen or 1.008 part of hydrogen or 8 part of oxygen or 35.5 part of chlorine by mass. You can also say 108 gram of silver. Here you can use silver also. So suppose you have any substance X. Let me give you an example to explain this. You have any substance X and 4 gram of X react with the 16 gram oxygen. It reacts with a 16 gram of oxygen. So students, what will be the equivalent mass of X? Now definition says whatever the mass of substance which reacts with the 8 gram of oxygen or 8 part of oxygen is equivalent mass. So here we say that 16 part of oxygen, it reacts with the 4 part of X. So what about 8? 8 will react with the 2 part of X. So now I can say that equivalent mass. Now what I will say, students, I will say that equivalent mass of X, it is 2. So this is the definition how we define the equivalent mass. Or you can also define the equivalent mass by this formula. Equivalent mass is atomic mass upon valency of the element. Now what is the valency? Valency of element can be defined in the different manner. Say for example, if you are calculating the equivalent mass of acid. For an acid, equivalent mass will be molar mass divided by the basicity of acid. Students, you must be knowing what is the basicity of acid. If in case you don't know, let me tell you, it is very simple. Whatever the number of H plus ions given by any acid, an acid gives how much number of H plus ion is basicity of acid. Say for example, if acid is giving 1 H plus, then its basicity is 1. If it is giving 2 H plus ions, its basicity is 2. For a base, what is the valency factor? Acidity. So for the base, equivalent mass is equals to molar mass upon acidity. Acidity is what? Number of OH minus ions given by base, because primarily base gives OH minus ion. Now equivalent mass of salt. For salt, whatever the molar mass or the formula mass of salt divided by the total charge on cationic part, or you can also use the anionic part, but please don't use both of them together. Total charge on cationic part or total charge on anionic part. If you ask, sir, will they be same? Yes, definitely they are same. It is salt. So the total positive charge or total negative charge amount, magnitude I am talking about, will definitely be same. Equivalent mass of oxidizing agent or a reducing agent in the redox reaction. Suppose if redox reaction is happening, what is the equivalent mass? In case of the redox reaction, equivalent mass is something very different. It is molar mass divided by the valency factor, definitely. And what is the valency factor here? Here the valency factor is number of electron lost or gained by one molecule of oxidizing agent or reducing agent. So during the redox reaction, how many number of electrons are lost or gained by one molecule of the oxidizing agent or the reducing agent is the valency factor, right? And here is the very important relation between molarity and normality. So molarity into molar mass is equals to normality into equivalent mass. So molarity is equals to normality into equivalent mass of solute upon molar mass of solute, which is 1 by valency factor. So finally, normality is equals to molarity, molar mass of solute upon equivalent mass of solute, which is also called as valency. So when you multiply valency with the molarity, it becomes normality. Now the another concentration term is mole fraction. Mole fraction is something very easy. It is just a ratio. It is ratio of the number of moles of a particular component to the total number of moles which are present in the solution. Suppose you have a mixture. Suppose you have this mixture. It is very easy. There are 3 components in this mixture, A, B and C. And number of moles of A are N1, for B it is N2 and for C it is N3. So this is the species and these are the number of mole. So what will be the mole fraction? As the definition says, mole fraction will be mole of any component. See, mole fraction we always define individually. First we define the mole fraction of A. That would be equal to the mole of A upon total mole. Now mole of A is N1 and total moles are N1 plus N2 plus N3. So this is the mole fraction of A. What about the mole fraction of B? Guys, mole fraction of B will be moles of B, that is N2 divided by N1 plus N2 plus N3, total mole. What about the mole fraction of C? 𝐿𝐶, which will be equal to the moles of C, N3 divided by N1 plus N2 plus N3. So this is how we define the mole fraction. Mole of any component divided by the total number of moles in solution. So mathematically, mole fraction of component is equal to the number of mole of the given component, particularly for which you want to find out the mole fraction, divided by the total number of moles in solution. It is dimensionless. Of course it is dimensionless. Mole will be cancelled out with the mole, so it is dimensionless, and it also does not change with the temperature. It remains constant with the temperature, because there is no component in mole fraction changes with the temperature. Another concentration term is the parts per million. You know guys, why we use the parts per million? Sometimes we have solution which are very, very diluted. Like say for example, when hormones are secreted in body, in the human blood, they are secreted in very, very small amount. So in case when solute is present in very small amount, we do not define its concentration in molarity or norm. Yes, we can. It is not like that we cannot define. Yes, we can define, but usually we don't. Why we don't? Because the value becomes very less. So in order to get some respectable value, we use the parts per million. Parts per million. Here we define concentration over 10 lakh, 1 million. So parts per million is defined as the mass of solute in grams present in 1 million gram of the solution. Whatever the mass of solute is present in 1 million part of the solution is called as ppm, parts per million. It is the mass of solute divided by the total mass of solution multiplied by 10 to the power 6. Normally we do multiply by 10 to the power 2, that is 100. But for this, we multiply it by 10 to the power 6. Right? So guys, this was all about the concentration terms we discussed today. We will continue this chapter and in the next class, I'll teach you something about the laws of the combination. Right guys? So this was all about this lecture. Thank you so much for watching this lecture. Keep studying and stay safe. Thank you.